Question number 2. Coast Guard Army detected a pirate ship 560 meters away from the land and started firing at pirates using a cannon placed at the entrance of the harbor. Right, practical question. From the projection, the time taken by the ammunition to reach the pirate ship is T. Write down an expression for T in terms of U and theta. Write down an expression. Therefore, we don't have to worry much about what do you call that, deriving it, but just let's quickly do it in a few seconds. We can finish it. Fine. So when you have a situation like that, what do you do? The yeah, what is it? The ammunition is fired from the cannon at an angle of theta at an initial velocity of u. So time here is 0 and here time is capital T. And what are we supposed to find out? We are supposed to find out, write down expression for T in terms of U and theta. Write down an expression for T in terms of U and theta. Good. Right. So easiest way to do this is, now, since they have not mentioned anything about AR resistance, you should know, at this point, now we know at this point there will be components of that velocity. Now people, yeah, this is U cos theta and this is U sin theta. And at the maximum height, we know the vertical velocity is 0, vertical component. But the horizontal component still remains u cos theta. So if I were you, I would have done like this. If the total time taken for the time flight is capital T, then at this peak, the time will be capital T by 2. Capital T by 2. So I'll take this position as A, I'll take this position as B. Then from A to B, if you apply V equals U plus AT upwards, v equals u plus at upwards, then what is going to be the equation? For final velocity, you have to put 0. For initial velocity, you have to put u sine theta plus. For acceleration, you have to put minus g, because this happens due to gravity, which is acting downwards, but I'm applying the equations in the equation in the upward direction into time is capital T by 2. All right. So you will end up gt by 2 equal to u sine theta, and final answer is going to be t equals 2u sine theta over g. But when we study about projectiles, we normally derive this equation. Equation for the time of flight. Okay, so if you can remember that, you could have directly written it, because they are asking to write down an expression. They are not asking you to uh, obtain an expression or derive an expression. So if you just write like this, it's more than enough. But careful, you can use this equation only if the angle is with the horizontal. Hope you understood this. If the angle is with horizontal, this is correct. But for by any chance, if they have given you the angle with the vertical, if this is theta, now you've got to be a little careful there. Here time is equal to 0, and when the object reaches the ground, if the time is equal to capital T. Now what is the equation for capital T? What change should I make, people, for this case? Anyone? 2u g. What should I do? Instead of sine theta, I have to go over cos theta, because in this case, vertical component is u cos theta, horizontal component is u sine theta. Okay, so this, fine. Let's move on to the next part now. Calculate the angle theta, which the cannon to be inclined to fire the pirate ship. Okay, they are asking us to find the value of uh, theta. Right, u is given 82, and the horizontal range is given 560 meters. Don't forget that horizontal range is given as 560 meters. Good. Right. So what's the plan here? Now, if you fine, if you apply the equation horizontally now, if you apply the equation horizontally, s equal ut plus half at square, we all know the horizontal displacement is 560, isn't it? 560 equal to u cos theta, actually. Don't forget about that. U cos theta into t, into capital T, plus this part is 0, because there is no horizontal acceleration in the system, only vertical acceleration. Therefore, we will be getting 560 equal, u is 82, no? 82 into cos theta into capital T. Capital T, we don't know it, capital T. Right, that is the equation. So we need to find out theta there. theta. Okay. No, no, we need to find out, yeah, angle theta. Angle theta. We don't know that. Uh, Good. So what's the plan here? Will we have to go for the will we have to go for the equation, people? Now there is this equation for horizontal range, that is r equals 2u squared sine theta cos theta over g in projectile motion. Okay, so the issue here is math students, they know 2 sine theta cos theta can be written as sine 2 theta. Sine 2 theta, that means now let's say sine 60 is equal to, now sine 60 you can write it like this, now we will sine 2 into 30, sine 2 into 30, so you can write it like this, that is going to be 2 sine 30 cos 30. That is the meaning of sine 2 theta equals 2 sine theta cos theta, right? Fine. So if we use this equation, then r will be written as 2 u squared over g into sine 2 theta. Why did I write like that? Because 2 sorry 2 sine theta cos theta, that whole thing can be written as sine 2 theta. Now using this equation you can get the answer because they have given you a sine inverse value. So let's see how far we can go with that. R is given to us. R is how much? 560 meters, equal to u squared is 82 into 82 divided by 10 into sine 2 theta. Okay, so if I continue, just put a star here and I'll continue the other side. This is star. Right. So I'll continue here. That will be 5600 divided by 82 into 82. And that is actually sine 2 theta. So when you divide these two, I think you will be getting this. If you divide this by this, you will be getting this most probably. Should we do that? 82 into 82. It is 164, 6, 1 balance, 65. That is 4, 2, 1 balance, 7, 6. So 5600 you should be aware, 6724. And I think most probably you will be getting this number. That is this number, 0.8326. Unfortunately, that is sine 2 theta. Sine 2 theta. Okay, that is sine 2 theta. And from that you can say 2 theta is equal to the value they have given. How much is that? 56. So theta is equal to 28. But everyone can't do this because there are students who do biology as well. So my advice, in such situations, you have to go to the logbook. No, you have to go to the logbook. There's no other option. You have to go to the logbook. Without that, you can't do this question. You can't do this question. Yeah. Without the logbook, you cannot find an answer for this people. Yeah. This is the only way you can do this. I don't see another way. Number 3. Calculate the angle alpha which the cannon to be inclined to the horizontal to fire the pirate ship at the same place with the same velocity. When it comes to a projectile motion, if you can reach the same range, same horizontal range using the same speed, but two different angles, one like this and the other one like this, two different angles. So this is u, and the range is same. For that to happen, let's say you are achieving it using two different angles with horizontal. I'll mark the angles. Let's say this angle is theta 1 and the bigger angle is theta 2. Okay, but the speeds must be same. Huh? The relationship between theta 1 and theta 2 is this. They are complementary angles, right? Now, for example, if you fire the cannon at 20 degrees Celsius with the same speed, and if your range is 560 meters, for example, no, in this case, let's go to the question. The question says one angle is theta 1 is how much? 28 degrees. If theta 1 is 28 degrees, theta 2 should be 90 minus 28 degrees. degrees, and that would be 62 degrees. You can achieve the same. Okay, 30, 60. Such another two pair, 30 and 60. If you want, I'll take 1 minute and very quickly explain it. Imagine you fired something at 30 degrees at a certain speed. You fired something at 30 degrees at a certain speed. Now, how do you find the range, people? I'll take it as R1, the first range. So the equation for R1 is equal to 2u squared over g sine theta cos theta. That is the equation. Fine. So I'll just leave 2u squared over g as it is into sine theta is sine 30. Sine 30 into cos 30. 2u squared over g into sine 30 is half into cos 30 is root 3 by 2. And if the angle is 60, it will become sine 60 cos 60. Sine 60 is root 3 by 2, cos 60 is half. So it is going to be the same number, root 3 by 2 into half and half into root 3. This part won't change now. Half into root 3 by 2. This part is going to be same. Sine 30, now what I'm trying to say is sine 30 cos 30 should be equal to sine 60 cos 60. Because these two are equal in magnitude and these two are equal in magnitude. That's how this happens. Okay, so this can happen if theta 1 and theta 2 are complementary angles, right? Next part, what is the assumption you made in this calculation? Obviously AR resistance is ignored. They had not mentioned anything about AR resistance, so we have ignored it. In reality, people, they are definitely, now if you are in a coastal area, there's going to be a lot of wind, no? So there's going to be a lot of AR resistance, but we are assuming that it's not there. And then I mean, since it's a cannon, we can assume that the effect of AR resistance is ignorable, right? Fine. What is the period of time taken by the ammunition to reach the pirate ship in the previous attack? In seconds. In the previous attack in seconds. Right, how long will it take? How long will it take for this thing? Okay, fine. We found an equation. Can you know we derived an equation? It was t equal 2u sine theta divided by g, isn't it? 2u sine theta divided by g. So the equation, the time is going to be 2 into u is given as 82 into sine theta now becomes sine 62. Sine 62, and you have divided by 10. Agreed? Sine 62 divided 10. This is how the equation is going to be. We have already derived the equation, so we can use this equation. No problem. We can use this equation. But this time theta is this new 62. Now, no other option. You have to go for the logbook. You have to go for the logbook and find the answer. Right? If you go to the logbook and find sine 62, what is the answer we are getting? I'm getting roughly around 0.88, 0.88, right? So it is 164 divided by 10 into 0.88, something around that. Right, fine. And final answer, it's going to be around 16.4 into 0.88. 0.9, roughly somewhere around 14.5, which is, let's say 14.5 seconds. Now, earlier step I did assuming that the question was about Roman 3, but it's incorrect. They're asking for Roman 2. In Roman 2, the angle is 28. So I have just changed it, sine 28. 164 divided by 10 is 16.4 into sine 28 is 0.47. 0.47 is almost half. So we can settle to our answer around how much? 8.1? Can we? 8. I'll just say 8 for the time being, 8 seconds. Okay, you can do the multiplication and get the answer. You can do the multiplication and get the answer. I'll settle to somewhere around 8. Right. And next question. What should be the inclination of the cannon from the above two angles to fire the pirate ship during a minimum period of time? Explain your answer. Fine. Now, there are two angles. We can fire, two angles at which we can fire the cannon to hit the pirate ship to get the same range. One angle is 28 degrees and the other angle is 56 degrees. Sorry, 62 degrees. 28 and 62. Now the problem is, now if you take T1, the time taken, total time taken, that is going to be 2u over g sine 28. And T2 is 2u over g sine 62. The time taken in both the projection. Now listen, in both the projections, the range is same, but the time taken will be different. And quickly tell me which value is the largest. Is it T1 or T2? Which value is the largest? Is it T1 or T2? Right, it's obvious, T2. Larger the value of the angle, larger is the sine value. Therefore, T2 is the largest one. Right, let's say, what are they asking for? Minimum period of time. That means your time should be less. Then your angle should be 28 degrees, right? Why? Because T is equal to 2u by g sine theta. Okay, when theta is small, sine theta is small. If sine theta is small, we can say time taken, it's small. When theta is small, sine theta is small, and then time will be small. Good, because other options, we are not changing anything else to people. We did not change the initial speed, and g is a constant, 2 is a constant. Therefore, t will depend on sine theta. Yeah. So 28 will be the answer. Next question: what is the safest minimum distance for the ship to avoid the avoid the attack? Now, talking about this question, we have to check the maximum range to which the cannon can fire the ammunition. To maximum range, the cannon can fire the ammunition. So, can someone tell me when do we get the maximum range? When will we have the maximum range? Arya, when do we get the maximum range? Can someone tell me very quickly? Yes, very good. When the angle with the horizontal is 45, or with the vertical for that matter, your range will be maximum. This is something you need to know about projectile motions. R will be maximum when your angle is 45. So, uh, the cannon can fire within this range. This is the maximum range. But it can control the range by changing the angle. But it can't fire above that. It can't fire more than this. This is the maximum range. All right. So if the ship is outside that firing range of the cannon, then the ship is safe. Hope you understood what I just said. All right. Now listen, using any cannon or any artillery or anything, you can't fire to whatever the distance you want. Every weapon has a range, and that range, the maximum range, we will get at 45 degrees if you ignore air resistance. Now, when there's air resistance and all, it will be different. But in this case, at 45 degrees, since we are ignoring air resistance, it will be maximum at 45 degrees. So if the ship is more than that, at a distance more than that, then it is safe. So first of all, we have to find the maximum range of the cannon. Maximum range of cannon. Right, now how are we going to find it? Maximum range of cannon, that should be equal to equation for r is actually r is equal to 2u squared sine theta cos theta over g. So let's substitute the value. 2u squared by g into sine theta, sine 45 into cos 45. Okay, what is sine 45? What are sine 45 and cos 45? 2u squared over g into 1 over root 2 into 1 over root. Right. When you multiply 1 over root 2 and 1 over root 2, it will give you half. There is another 2 here, right? That 2 and this root 2 will get cancelled off. Finally, you will get the maximum range equals u squared by g. And I think they have given us the value of u squared. It was 82 into 82 divided by 10. Right. So what was 82 into 82? We found it, but forgot, right? 164, 6, 1 balance, 65. Therefore, 4, 2, 7, 6. 6, 7, 4, 2 over 10. And that is going to be 674.2 meters. If the ship is at a distance greater than this from the cannon, then the cannon can never hit the ship. The ammunition fired from the cannon can never hit the ship. So this is the minimum distance between should be for the ship between this should be the minimum distance between the ship and the cannon for the ship to avoid getting damaged. That's what they are asking. All right. If you if you go below that, then if you go less, if your gap is less than that, then the ship is in the danger of getting attacked. Okay. So the maximum range of a cannon or a projectile path is obtained when the angle is 45. So we found the maximum range, and if the ship is at a distance more than that, then the ship is safe. So this should be the minimum distance for the ship to avoid getting avoid from being attacked. Right. What is the maximum height which the munition reach at the situation given in 4 above? Okay. So they are asking for the maximum height. Well, we all know at the maximum height, the vertical velocity is going to be 0 and the horizontal velocity will be there. The maximum height must be found, right? Capital H. And initially, the vertical component is u sine 45. Actually, u sine 45, but both cos and sine 45 are same. But anyway, regardless, let's go with the common equation. So that is actually u divided by root 2. U divided by root 2. I'll take this point as x and I take this point as y. There is an equation for maximum height, but it's better if you go with the equations of motion from x to y. Let's apply v squared plus v squared equals u squared plus 2as upwards, because I know the final velocity upwards, that is 0. What is the initial velocity upwards? That is u divided by root 2 squared plus 2 into 4. I have to put minus 10 because gravity is vertically downwards, but I'm applying the equation upwards into the maximum height, capital H. Therefore, this goes the other side, we'll be getting 20 capital H equals to this here. It is actually 82 divided by root 2 squared. That is 82 into 82. What is root 2 squared? That is 2. Finally, h will be equal to this value. What is it? 6, 7, okay. 82 into 82 divided by 2 into 20. 2 into 20. Right, let's simplify them and try to do it convenient way. This is 41. And then if you simplify this 10 here and another 41 here. So 41 into 41 divided by 10. 41 into 41 divided by 10. 41 into 41 is 410 plus 41, 451 divided by 10. I think it is 45.1. 45.1 is the final answer. Because 41 into 41 is 451. If you divide by 10, 45.1 meter. 45.1 meter is the maximum height when the angle is 45. And for this speed. So beg your pardon. Earlier I made a mistake when you multiply 41 and 41. It should be 168.1. Sorry, it's not that. 1681 divided by 10. So this should be the correct answer. Earlier I had multiplied 41 by 11 by mistake. Sorry. Right, let's move on. At the instance of emerging of the ammunition, the pirate ship fleeing at a velocity of 20 meters per second, what should be the velocity of ammunition to fire the ship during the time period in 5 above? Okay. We have to go back to 5 and see what they're talking about. In 5, Roman 5. Now, the last part, this is what the question says. When the cannon fires the ship, cannon fires the ammunition, initially the ship is at a distance of, what is the distance between the ship and the cannon? It is 560 meters. Okay, right. Now what's going to happen? This is what's going to happen. Ship is going to move as now when time is equal to 0. Okay, time is equal to 0. That is when the cannon is fired. The ammunition is fired. Time is equal to 0. The ship is here. Time is equal to 0. Here also time is equal to 0. Right? Ship is moving forward at a constant velocity of 20 meters per second. And when the ship has reached a certain distance like this, eventually the ammunition, it also hits the ship. It also hits the ship. So they're asking at what velocity we should fire it in order for that to hit the ship. Okay, right. So the time taken, Okay, right, fine. And and it has taken 8 seconds. Remember, it has taken 8 seconds. Now, when the cannon, I will draw the ammunition actually, ammunition. I'll draw it in black color. Read the question carefully again. At the instance of emerging of the ammunition, at the instance of the emerging of the ammunition, that is this t equal to 0, the pirate ship fleeing at a velocity of 20 meters per second. The pirate ship starts fleeing at 20 meters per second. That's why I put t equal to 0 here also. T equal to 0 here, right? And then how long does it take for the cannon, for the ammunition to hit the ship? It takes 8 seconds. Why? How do I know it's 8 seconds? How do I know it's 8 seconds? Because they have told to fire the ship during the time period in 5 above. Okay, so the time period in 5 above was 8 seconds. So 8 seconds. That means what is the distance traveled by the ship then, people? What is the distance traveled by the ship in those 5 seconds? Sorry, in those 8 seconds. This is the distance traveled by the ship in those 8 seconds. I'll take that distance as x, and very easy to find x. You can say s equal vt for the ship. Okay, for the ship. What ship? Pirate ship. Okay, pirate ship. You can use this equation. S is x. Speed of the pirate ship is 20. Time is 8. Therefore, x is equal to 160 meters. Okay, 160 meters. So, total range of ammunition is how much now? Total range of ammunition is how much, guys? That is equal to, tell me quickly, that is equal to 560 plus 160, that is 720 meters. 720 meters. Because between the cannon and the ship there was a gap of 560 already, and the ship is moving now. So when the when the ammunition hits the ship, total length between the ship and the cannon will be 720. Okay, so if the total range of the ammunition is 720, for projectile path, let's apply this equation for projectile path. Let's go with, for projectile path, I'll go with horizontal s equal ut plus half at square. Let's apply that horizontally. Now we have supposed to find out this v, and don't forget the angle. Angle is 28, if I can remember right. Angle is 28 because in Roman 5 the angle was 28, right? And this horizontal component is v cos 28. Horizontal component is going to be v cos 28. Go back to Roman 5. In Roman 5, we found the time taken for Roman 2. In Roman 2, the angle was 28. So we have to take the angle as 28. Good. And then horizontal displacement is 720. Velocity, we have to find it. Velocity is not v, which is v cos 28. V cos 28, sorry. And the time taken is 8 seconds. Plus this part, half at squared part, is going to be 0 because there is no horizontal acceleration. Well, therefore, this 8 and 720, you can simplify, it will be 90. I am getting v equals 90 divided by cos 28. Right, 90 divided by, let's check the logbook very quickly. Cos 28. Cos 28 from the logbook. Cos 28 from the logbook. How much is that roughly? 0.8829 roughly, 0.8829. Fine. So 90 must be divided by this, and when you divide 90 by that, we can assume the answer is around roughly around 102 meters per second. Earlier it was 82. Remember? Earlier the speed was 82 because we wanted to hit only 560 meters. But now, since the ship is moving, we need to hit the ammunition further. Therefore, we have to hit it at a higher speed. So 102, it looks like a quite reasonable answer because it's more than 82 and ship.